Let's analyze and solve the longest palindromic substring coding problem. We are given a non-empty string S that consists only of digits and English letters, and we have to find the longest palindromic substring within that string S. Palindrome is a string that reads the same backwards and forwards. In the terms of coding, we have to write a function. We can call it longest palindrome. The function will receive one argument, which is our string S, and it will have to return the longest palindromic substring it can find within the string S. We are also given a set of constraints. We are being told that the length of the string is greater equal 1 and less or equal 1000. And what we already said, the S consists only of digits and letters. And the key point is that the substring must be contiguous, which means it is a substring, not a subsequence. And that's the entire problem we have to solve. Before we start solving this problem, let's learn a little bit more about the palindromes. So there are two types of palindromes. One type has an even number of letters, and there is another one which has an odd number of letters. And let's start from the first type, the one with an even number of letters. The way we can create such a palindrome is we could have like imaginary vertical line, which indicates the middle of the palindrome, and we can keep adding the same character on both sides of that line. So let's say I add A here and A here. I have a string which reads the same backward and forward. And I can add a different letter like B and B, and it will still be a palindrome. And I can add either a different letter or the same letter. Let's say I add A again. And this way we can create more and more palindromes. And these will be the palindromes which have even number of letters, because each letter inside the palindrome occurs an even number of times. How can we create a palindrome that has an odd number of letters? We can create it by simply putting a letter in the middle of the palindrome that has an even number of letters. So let me show you how. Let's say we take this palindrome and we put a letter C in the middle, and then we keep the rest as it was before. So C-A-B-A and A-B-A. And this palindrome has an odd number of letters. It has 7 letters. And every letter in the palindrome, except for the letter in the middle, occurs an even number of times. And the letter in the middle can be any letter. It can be a different letter, like in this case, it is a C, or it can be a letter that already exists inside the palindrome. I could have put A here, and it would still be a palindrome. A, B, A, B, A. So that's the clarification about the types of palindromes. And we also need to find a way to check whether a given string is a palindrome. So let's say we have a string A, B, B, A. How can we check whether this string is a palindrome? We can have a index that starts at the very beginning of the string. We can call it left. And we can have another index that starts at the very end of the string. We can call it right. And then we can repeat the following steps. We check whether the letter pointed by left and letter pointed by A are the same. If they are the same, we continue. If they are different, that means the string is not a palindrome. If they are the same, we continue, and that means we will move left towards the center and also right towards the center, and keep checking whether the letters are the same. And we are doing this as long as left is less than right. And if this condition becomes false and all the letters we processed were the same, that means the string is a palindrome. Otherwise, we would have exited that loop with the value of false. That would mean that the string is not a palindrome. And that's what we need to know before we start solving that problem. To solve this problem, let's start from a simple brute force solution. And let's use the string BACAD as our example. And the brute force solution will use the fact that we know how to check whether a string is a palindrome. So what we can do is for a given string S, we can generate all possible substrings of that string. And for each of those substrings, we can check whether that substring is a palindrome. And if it is, we can store this substring as our current longest one and continue checking. Once we process all the substrings, we will have the longest possible substring stored on a side and we can just return it. So now the problem is only how we can generate all possible substrings. We can do it as follows. We can have a pointer that starts from the first letter. We can call it start. And what we are going to do is that we will generate all the substrings that start from a pointer start or index start. So all the substrings that start from letter B. And once we do that, we will move the start index to the next letter, to letter A. And we will generate all the substrings that start from letter A and so on until we reach the end of our string. What that means in terms of coding, that we will have a loop, for loop, which will go from index 0 up to the length of the string. And for each of those, we will have to do something. And what we will do is we will have a second for loop, which will start at the same position as our start. We can call it end. And the index start and end will denote our current substring. So in this case, start is B, end is B, so the substring is just B. This is our first substring. What we will do, we will move the end pointer to the next letter, and our substring will be BA. And we will continue, we will move it to the next letter, and the substring will be now BAC. And we will do it until we reach the end of the string, and the last substring would be BACAD. At this point, we generated all substrings that start from B, so we would move our start pointer to point to letter A. We will reset the end pointer to point to the same position as start and continue the process. So that's how we generate all possible substrings. Since we have two nested for loops, the cost of generating those substrings will be O of n squared when n is the size of our string. And for each of those substrings, we already showed how to check whether the substring is a palindrome. We use two pointers, one starting from the end, one starting from the start, and we check whether the letters pointed by those pointers are the same, and we continue moving towards the middle of the string. So we have to go through the entire string. So checking whether the substring is a palindrome has a complexity of O of n. So the total time complexity of our brute force algorithm is O of n cubed. The space complexity of this algorithm, just the part when we are looking for a longest palindrome, is O of 1 because we are not using any additional memory. But you can argue that the space complexity is actually O of n because we are returning the string. So at the end, we have to make a copy of our input string, at least part of it, and return it back. So we could argue that the actual space complexity is O of n. And with that small caveat, these are the complexity of this algorithm. To find an optimal solution for this problem, let's analyze the following two strings. We have a string on the left, which is DABBAC. It has 6 characters, and we have a string on the right, which has 7 characters and is DABCBAC. And the string on the right was created by inserting a letter C between those two letter B's. Otherwise, those two strings are the same. And the way we are going to solve this is we will be starting from the middle of those two strings. and we will have left and right pointer, and we will be trying to start from the middle and expand outwards to find the longest palindrome. So let me show you how it works. We will have two pointers, left and right, and we will point them initially to the two characters in the middle, and then inside a loop we will be doing the following. As long as those two characters pointed by the two indexes or two pointers are the same, we will be moving the left pointer towards the start of the string and the right towards the end of the string. So we would move it to the second A. And again, we will compare whether the two characters pointed by left and right are the same. If they are the same, we will move right towards the end and the left towards the beginning and do another comparison. And in this case, D is different than C. So we will exit our loop, and what we would find is that the longest palindrome for this specific case is ABBA. And the way we would find it, we would track something like start position or start index. In this case, the start is the first A, which has index 1, so the value would be 1, and the length is 4. And inside our loop, we would keep updating those two variables. And after we exit the loop, we would know that we have to return a substring of our original string that starts at index 1 and has a length equals 4. And that's how we can do it if the string is of even length. If the string has an odd length, the algorithm would be the same, except the initial position of both left and right is such that it points to the same character. So left and right point to letter C. And with this small change, the algorithm is the same. So we would have a loop, and inside the loop, we would be comparing whether the character pointed by the left and by the right are the same. In this case, both point to C, so they are the same. And if they are the same, we would move the pointers. So left would be pointing to B, right would be pointing to the second B. And again, we would compare, they are the same. So left would be pointing now to A, right would be pointing to the second A. And again, they are the same. So we would move them. So the left points to D and the right would point to C. And the characters are now different. So we would exit our loop, and the longest possible palindrome inside a string S we were able to find would be ABCBA. So the start index in this case would be again 1, but the length would be 5. And that's pretty much the main idea behind the optimal algorithm. What we have to pay attention to is that the string might not be such a nice symmetric string. It can be something like, for example, so we have a string A, B, B, A, C, D, E, and as we can easily notice, the longest palindrome is still A, B, B, A, but it is shifted towards the left side or the beginning of the string. So if we were to use our previous approach and start in the middle of the string S, we would never be able to find that longest palindrome. But we can still use the previous idea, except that since we don't know where is the middle of the palindrome, in this case the middle is those two letters, and we don't know where they are for that specific string, what we would do is that we would go through the entire string S, starting from the beginning until the end of the string, and we will try to set the middle to each and every character as we go through. What that means is that we will start from letter A, and we will assume that our left and right pointers are both pointing to that letter A, and we will try to use one of the above two approaches and expand and try to find the longest possible palindrome. And then we will make a change, and we will start from, again, letter A, but point the right to its neighbor. and again try to expand from this position. So this would be the assumption that the longest palindrome has even number of letters, and so on. So once we do that, we will find the longest possible palindrome from that position. We would then move our starting position to the next letter. That will be the assumption that now this is the middle. And again, our left and right pointer would initially point to that single character. This is the assumption that the palindrome has odd length, and we will try to expand. And then we would change and assume that the palindrome has even length. So we would set the pointer to the next letter after our current start position. And then we would do the expansion. And this is the case when we would actually find the longest palindrome, because the b is equal to b. So we will move towards the end and left towards the start. A is equal to A. We would again try to move, but since left is at the beginning of the string, we would have to exit our loop because we are going out of the boundaries of the string. And we would find that this was the longest palindrome, but we would still continue. So in this case, we would put the note that the start index is 1 and the length is 4, the current longest palindrome, but we would still continue. We would move the current middle to this B, and so on. We would be moving this start pointer, which is indicating our middle, until we reach the end of the string. And then when the algorithm would end, and what we've done is we basically tried to expand from each and every position in our string. And since we were doing this, we should find the longest possible palindrome because we are trying each and every middle position in our string. And the complexity of this algorithm is O of n squared. The first n comes from the fact that we have to move our middle position, the one at the top, through the entire string. So this is O of n operation. And the expansion is also O of n operation. So the final time complexity of this algorithm is O of n squared. And the space complexity is, again, we are not using any additional memory to find the position of the longest palindrome. So from that point of view, we could say it's O of 1, but since we are returning a string, in the end, we will have to copy the return value. So we would have to copy and make a substring from S, starting from our start index, and take the len number of characters. So we could say that if we account for the copy of the result, the space complexity is O of n. And that depends on how interviewer is willing to interpret the returning of the result. The safe guess is probably to assume it's O of n. And that's the optimal solution for this problem. Let's write code for our solutions, starting from the brute force solution. First thing we are going to do, we will create a utility function called isPalindrome. We will use it to check whether a substring is a palindrome. So our utility function will have 3 arguments. The first one is a reference to our string. We can actually make it const. And the left and the right indexes. And then we will use algorithm that we explained in the solution. And the algorithm is that we will position left at the beginning, right at the end, and we will keep comparing the characters pointed by those 2 indexes. And if they are the same, we will keep moving indexes towards the center of the string. And when they cross, we will exit the loop and return true. So the above code does what we just said. We check whether the L is less than right. And if they are, we compare the characters pointed by those 2 indexes. If they are different, we return false. Otherwise, we increment left index, decrement the right index, and continue until we are either returning false from line 9 or we exit the loop, in which case all the characters were matching and we can return true. Now we can move to our longest palindrome function. The first thing we are going to do, we will store the size of our string s in a constant. We will check whether the size is less than 1. If it is, then we will return the string. So what we are doing is we are checking size. If it is less or equal than 1, then the longest palindrome is the string itself, which means if the string has a size 1, it's just one character, the longest palindrome is just that string. If this string is empty, we also return empty string as the longest palindrome. Now let's define the start index and length that will be tracking our maximum found substring that is a palindrome. So we initialize start index to point to the first character, and the length of the maximum substring that is a palindrome, we initialize it to 1 because we consider the first character to be a longest palindrome we are able to find so far. Now we will process string s and generate all possible substrings, and for each substring we will be calling our isPalindrome function. So we have two for loops. The outer for loop, which is our starting position, which says that we are going to generate all the substring for a letter starting at s of I. And then the inner for loop is what generates all the substrings. And now what we have to do, we have to compute the length of the current substring. And we will compute it as j minus I plus 1. And now we have to check whether the substring is a palindrome. And if it is, we will check whether the current length is greater than our length. And if it is, that means we found the longer palindrome. So we will note the start index and the current len. And that's all the code for the substring generation and checking whether the substring is a palindrome and picking the longest palindrome we are able to find. What remains is to return the substring we have found. And that's the entire code for our algorithm. Let's try to build it. It builds okay. Let's try to run tests. All tests have passed, so we successfully coded a brute force algorithm for our problem. Let's now write the code for our optimal solution. We will start from storing the size of the string. If the string has size 1 or it is empty, we can return the string itself as its longest possible palindrome substring. Otherwise, we are going to define two variables, start index and len, to track the position of our longest possible palindrome substring as we are processing the string s. So we initialize start index to 0, which is index of the very first letter in our string, and the length 1, and they both together mean that we consider the very first letter in our string s to be the longest possible palindrome substring so far. Now, in this algorithm, we are going to be expanding from the middle, and the idea is that if we are in the middle of the longest palindrome, by expansion we will find its length, but we don't know where is the middle of the longest possible palindrome in our string s, and because of that we will try all possible positions inside our string s, and we will consider each of them to be a middle, and then we will check whether we can get the maximal possible palindrome substring from that particular position. So let's write a for loop. And inside our for loop, let's assume we have a function. Let's call it expand around center. And we will be passing left and right pointer to that function. So initially we will pass just I, and this is the case when we are assuming that our longest possible palindrome is of odd length. So in that case, both left and right start from pointing to the character in the middle of the palindrome. But we will also check the other case where the left points to the current center or current I, and the right points to the one character to the right of left. And this is covering the case when the palindrome is of length which is even. And the assumption is that the expand around center will do the expansion from the middle, and as it is doing that, it will update the start index and len accordingly as it is finding longer and longer palindromes. So what we are missing now is that expand around center function, and we will define it as a lambda. And lambda in C++ is an object which we can execute. We can think about it as a function, and it takes arguments, which in our case are left and right, but it also has something called lambda introducer, and this allows us to access variables which are outside of the lambda definition. The ampersand means that we are accessing them by reference because we want to change those variables. We want to update the index and the length, so we have to be able to access them by reference and modify their value. The other option would be the equal sign, in which case we would be accessing them by value. And the code for the lambda is as follows. So we start from a while loop which does the expansion, and what we are doing, we are checking first if left and right are within the bound of our string. So left has to be greater equal 0 and right has to be less than size. And then as long as the characters pointed by those two indexes are the same, we will continue expanding. So we will be moving left towards the beginning of the string and the right toward the end of the string. At some point, we will either exit because we are going out of bounds or the characters are different. In any case, when we exit this loop, the left and right are pointing outside of the longest palindrome substring we were able to find by that expansion. In other words, the S of left and S of right, after we exit that loop, they are not part of our longest possible palindrome. So they are the first characters that we have to ignore. So with that in mind, we can compute the length of the longest possible palindrome we were able to find. And after that, what we have to do, we have to check whether that length is greater than our current len. And if current len is greater than len, that means we found the longer palindrome that we used to have. So we need to update both start index and len. So the start index becomes left plus 1 because the left is outside of the palindrome, as we said before. So the palindrome starts from the character left plus 1, and the length of that palindrome is current len. And that way we keep start index and len up to date as we go through the string and as we are finding longer and longer palindrome substrings. With that, our algorithm is complete. What remains to be done is just to return the result. And the result is simply a substring of S that starts from start index and is of the length equal len. And that's the entire algorithm. Let's try to build it. It builds okay. Let's try to run tests. All tests are passing, so we successfully coded optimal solution for this problem. Let's see if our solutions are passing all LeetCode tests. Let's start from the brute force solution. Let's see if this solution works. It works. Let's submit. We were able to submit, but execution time is pretty bad because it's a n-cubed time complexity solution. So let's now try our optimal solution and see if we get an improvement. Let's see if this solution works. It works. Let's submit. And we got a much better performance. So both our solutions are passing all LeetCode tests. That is the end of this solution. The source code is available in the GitHub repo shown on the screen.